Hey, this next video is on solving systems of equations using elimination. Check out the other two videos I have using different methods.
So let's get started. Here you got a system of equations, and this is a good one to solve by elimination. Elimination is my favorite way to solve a system of equations because you can do it with any two equations. So here I got two equations that make up a system, and what we're looking for is where, if you had a graph, where these two lines will intersect. Both of these are linear equations, so they can be represented by a line, and we're looking for where they intersect. There's a couple ways of doing this, but my favorite is elimination. So if I take these two equations and I add them up, what I'm going to do is end up canceling out the x term, because I'm adding 2x minus 2x, which is 0. So 2y plus 6y is 8y, and then I get a 0 here, and then 6 plus 10 on the other side is 16. Now that boils down to 8y equals 16, and what I can do here is divide by 8 on both sides, and I get that y is 2. Now that I know y is 2, I can take this answer and put it back into either one of these equations. So if I just put it in the top equation, I'm going to replace y with 2. So I just put parentheses around that thing that I substituted in, and I get 2 times 2 plus 2 times x equals 6, and here 2 times 2 is 4, so I get 2x. 4 plus 2x equals 6. Subtract 4 from both sides, and I get that 2x equals 6 minus 4 is 2. Now I divide by 2 on both sides, and I get that x is 1. So this will be the second part to the answer. So the answer really is this point where x is 1 and y is 2. That point is where these two lines cross. Incidentally, if you were to put that y equals 2 into this equation, you would still get out 1 for x, because you'd have, well, I'll let you look at that and see if you can see how you get out the same number no matter which equation you pick to substitute in. This next problem sets up well for elimination too. Now you notice this one is not set up the same, but I have a y on both of them. I have a y on one side and the x on the other side of the equal sign. And when I add this up, y plus y, so I'm adding y plus y is 2y equals positive 3x plus negative 3x is going to be 0, and then 4 plus negative 6. That's how I look at that. Is well, negative 4 plus negative 6 is negative 10. So anyway, I end up with 2y equals negative 10, y equals negative 5, dividing both sides by 2. So if I take negative 5 and I put it into either one of these equations, I get my answer for x. So if I take this top equation, I have this to work with, and like I did before, I'm solving for x. I'm trying to get only x on this right side, so I add 4 to both sides, and negative 5 plus 1 is negative 1, and on the other side I get 3x. Next I divide by 3, because I'm trying to get x by itself, so I get negative 1/3 on one side and x on the other side. So my answer, my solution is this one point. This next equation is a little bit more difficult, because what I got here is, if I added 6x plus 4x, I get 10x. If I add negative 5y plus 15y, I get 10y. So neither one of them get eliminated. But what I can do before I add these two equations is I can change one of them or manipulate it into something equivalent and then add. So if I call this the first equation, and this one the second equation, if I take that second equation, I can change it around a little. What I do here is I see that if I had a, well, actually I'm going to take the first equation and change it around. Sorry, let me back up. So this first equation, if I had a negative 15 here, then it would cancel out with a y. So what I'm going to do is I'm going to multiply by 3. So let me run it like this. I'm going to multiply this whole thing by 3. And I probably shouldn't put a x for times, but times 3. Now what I'm saying here is I'm multiplying the left side by 3, this whole left side by 3, and this whole right side by 3. So I'm allowed to do that because as long as I do the same thing to both sides, then the equation is still balanced. So I have an equivalent equation. So when I do that, I get 18x minus 15y equals 25 times 3 is 75. So with that, I have my equation 1 rewritten into an equivalent form, and I'm going to add equation 2 to it. And my writing's getting a little bit crooked, but this is equation 2, so 15y equals 13, and I add them together. 18 plus 4 is 22, so 22x. Negative 15y plus 15y is going to be 0, and then 75 plus 13, and this is going to be 8, and the 8 here, so I have 22x equals 88. If I divide both sides by 22, and you can check this, but 22 goes into 88 4 times, so x equals 4 here. And then I just had to figure out y. So going back to, let's use equation 2, I'm going to put in 4 for x plus 15y equals 13. Now I'm looking for my x term. So this is a 16 plus 15y equals 13. If I subtract 16 from the left side and 16 from the right side, I get 15y equals 13 minus 16, so that should be a negative 3. Divide both sides by 15, and I get y equals negative 3 over 15, which 3 goes into 3 one time, 3 goes into 15 5 times. So here I don't have a whole number or integer, I have a fraction, which sometimes that comes up. And actually when you're doing elimination, it's actually easier to come to an answer like a fraction as opposed to graphing. And substitution will work here as well.
Thanks for watching. There are 2 other videos you should check out, and I may do another follow-up. There's one more video I need to do where you have parallel lines and where you have 2 lines that are actually the same line, and how those show up when you're going to solve a system of equations.